Hello, students. In the very same series, we have a theorem here that the bisector of the angles formed by the producing the opposite sides of the cyclic quadrilateral intersect at right angle. Okay, so basically, this is a question from the cyclic quadrilateral. We have a circle, and inscribed of that uh, quadrilateral is there. So basically, we know that cyclic quadrilateral is that quadrilateral which inscribed in a circle. So basically, this question says that when we producing the opposite sides of the quadrilateral and where there both the sides are intersecting at some place, that angle when that angle formed and the bisector on both the angles are intersecting at right angle. Okay, so basically we are mm, we are solving the theorem here. So to better understand, so to better understanding of this question, we have to first draw the diagram so that we can easily understand what the question is and what the question asked. Okay, so starting with the circle, starting with the circle. Okay, uh, this is our circle. Sorry, this is our basic circle. Okay, let us draw another circle so that we can easily understand it. So increase the thickness. So this is the circle we have. Okay, this is the circle we have here. This now, this is the very circle which is asked in the question, but there is a cyclic quadrilateral that is a quadrilateral inside a circle. So, starting with the circle, we have a quadrilateral. So, we are making this quadrilateral. So, we are making quadrilateral here. We can increase the thickness and change the color so that we can easily understand it. Okay, this one and another one will formed here somewhere. This one and this will extend it to a part over there, and this is the side which is passes through this. Okay, let us draw basically this one and this over here. Okay, this one is from here, here. Okay, and this one is extended to here. Okay, now this has become a cyclic quadrilateral. Okay, now what the question is that we have a cyclic quadrilateral and producing both the opposite sides of the quadrilateral and that angle, which is this one, this angle and this angle. Okay, so both the angles, both the angles will be bisected by some lines. That is making a bisector here, making a bisector here. This one is the angle bisector. Okay, we can increase the width and change the color certain color. Okay, now from here also angle bisector is there. So change the color. So basically we have a diagram here. Now we are uh, we are marking them. We are giving names to them so that we can easily understand what we are trying to solve here. Okay, so this one will, okay, first of all, this one is A, this one is A, okay, this one will be, this point will be B, little bold, okay, and now this one will be C, and this one will be D, okay. Now we have a quadrilateral A, B, C inside in a circle. So we are extended BC and AB. Okay, both are the opposite sides of the cyclic quadrilateral. So we are giving the name that this one is P, this one will be P, and this one will be Q. Okay, now we have PQ, and this one will be, this one will be S. Okay, and name it this point as L. Okay, so basically we have a drawing here. Make this one will L, and this one will be R. Okay, so we have P, Q, R, and S, and A, B, C, D are the quadrilateral of the cyclic quadrilateral. Okay, now understanding this question first. Okay, so we are extending this here so that we can easily answer the question. Okay, now starting, what is the approach in this question? So first of all, as we know that we are giving example, we are giving given here. We just write here the given what we have. First of all, we have to write that what we have. So basically, we have a cyclic quadrilateral, cyclic quadrilateral. So basically, we have a cyclic quadrilateral A, B, C, D, which is here A, B, C, and D. Okay, and in which, sorry, in which AB and AB and DC. Okay, when produced, meet at point P. Okay, and produced meet at point P. Okay, so and AD and BC when produced when produced meet at meet at Q. Okay, so now bisectors 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 of angle angle P and an angle Q. Angle P and angle Q at a meet at a certain point, that is R. Okay, this one. This bisector and this bisector meet at point R. Okay, so now what we have to prove? To prove what we have to prove here. Basically, we have to prove that PR is perpendicular to perpendicular to which one? That is QR. QR or QS. We can say that this is QS. Okay, that is what is what it is. That is angle. Sorry, angle PRQ equals to angle PRS equals to 90 degree. That will be this one. PRQ and PRS. P this one. I can mention it here that PRQ and PRS both are 90 degree. Okay, that will be our question here. Okay, now starting with this. Sorry, starting with this. So basically, we have a approach that we have given here, and what we have to prove. So, what will be the proof here? Now, starting with the proof. So, produce QR, produce QR to meet AB and S, that is there. Suppose QR meets CD at L, that will be there. Okay, sorry. That is our construction here. Okay, sorry. Now this is proof. Now starting with the proof. Okay. So in triangles, which one? Q, D, L, and Q, B, S. We have what we have. That is, I can show you there. Q, D, L, this triangle, and Q, B, L. That is Q, B, S. That this one. Sorry, Q, B, S. This triangle. Okay. We have to consider this one. We have to consider these two triangles. Okay. So we have basically taking this triangle, and now we mentioned the angles here so that we can easily understand what angle we are talking about, which angle we are talking about. Okay, so this one and this one and this one, both are equal. This one and this one, both are equal because PR is the bisector of angle APC, and QS is the bisector of angle AQB. So, okay, this one. So, this we have, okay, this is the basic idea of this question. So, we are mentioning it as this one is angle 3. Okay, let make it small so that we can easily send it here and we can easily write over there. And 4, this one will be 4. Okay, let us zoom out and write over there. This is 1 and this is 2. Okay, this will be the angle 2 here. So basically we have a question here that now these angles are 3, 4, 1 and 2. Okay, these are the questions. So we can easily write here that these are the angles 1 and 2 and 3 and 4. Okay. In the triangle QDL and QBS, angle, sorry, angle, which one? Angle 3 equals to angle 4. Okay. Since since is QR is the bisector of which one? Bisector of angle, whole angle Q. Okay. Now considering Now considering considering triangle QDL and QBS. Okay, considering triangle QDL and QBS. So angle 3 and angle 4 are equal because of QR as the bisector of Q. Okay, bisector of whole angle Q. Then now considering this one. So therefore, therefore angle 3, angle 3 plus that one, that as angle QDL equals to angle 4, that is angle 4 plus angle which one? That is QBS and QBS, that is QBS. This one, QBS, this angle. Okay, I can mention it as, sorry, I can mention here that QBS and that will be QDL. Both are equal. Okay, both are equal. Now, okay, so now angle 3 plus angle QDL equals to angle 4 plus angle QBS. So 180 degree minus angle, that is DLQ. DLQ. This one. This DLQ. Okay. This one equals to 180 degree minus which one? That is QSB. That will be QS and B, because this angle plus this angle will be equals to 180 degree minus this angle, because angle sum property. Okay. Now angle QSB. Since angle 3 plus angle QDL plus angle DLQ equals to 180 degree by angle sum property, by angle sum property. See, clear it is? So angle angle which one? So angle D DLQ equals to angle GLQ equals to angle QSB. This angle QLD equals to angle QSB. I can mention here so that you guys can understand. I can zoom in. This angle, sorry, this angle and this angle will be equal. Okay, as it is clear. Okay, now starting with this one. Okay. Now angle DLQ. DLQ will be equals to angle QSB. This is our uh, half part of this question. And now we are starting with the uh, triangle, that is QLD and QSB. That will be the both the triangles, and angle Q, that is QLD, equals to angle PLQ, because both are vertically opposite angles. That is PLS and DLQ, both are equal because of the. Okay. Now starting with this. So angle PLR equals to angle QSB. Okay. PLR equals to QSB, since angle PLR equals to, sorry, PLR equals to angle DQ DLQ, that is by vertically opposite angle. Vertically opposite angle. So clear? This angle and this angle will be equal. So angle PLR equals to angle QSP equals to angle RSP equals to angle PSR. That will be equal. All the angles are equal. So making it as equation first. So this one will be equation first. Okay. Now in triangles TRL and PRS, we have what we have, that is PRL and PRS. So what we have, that will be angle 1 equals to angle 2. Okay, because since PR is the bisector, angle bisector. Okay, is the bisector of the angle, which one? Angle P. Okay, so and and angle PLR equals to angle PSR. Okay, so that angle 1 plus angle PLR, sorry, PLR equals to angle 2 plus angle PSR will be equals to 180 degree minus 180 degree minus angle PRL equals to 180 degree minus angle PRS. Okay, since These angles, these two angles are equals to 180 degree minus that angle, that is PRS. Okay, so change the color so that we can understand easily. Now this proves that angle PRL equals to angle PRS. This one, PRL equals to PRS. Okay, so these angles are equal. So these angles are equal. Now, but SL is a straight line. Straight line. Which one? This one. SL is a straight line. So this is a straight line, no? So basically, this is a straight line. That's why we are using the linear pair. Okay. Therefore, angle PRL plus plus angle PRS will be equals to 180 degree because of linear pair. Because of linear pair, we know that the uh, due to the linear pair, both the angles will be 180 degree. That will form the 180 degree. Which one? I can mention here this angle. This angle will form the this angle will form 180 degree. Okay. So now starting with this one. Okay. So therefore these angles form 180 degree. So if we write that two angle of PRL equals to 180 degree, that will be also fine. So angle PRL equals to PRL equals to 180 degree divided by 2, that will be equals to 90 degree. So this proves that angle PRS also equals to 90 degree, as it is clear that hence angle PRL equals to angle PRS equals to 90 degree. This will we have proved that TR is perpendicular to LS. Okay, so basically it that proves that PR is perpendicular perpendicular to LS. Okay, guys, thanks, thank you, and mm, I will out zoom out it so that you guys can easily understand the whole question here. Okay, this is the theorem here, and this will be the question here. Okay, you guys can easily understand. This is the question. We have a question here. I can increase the size, and this will we have proved here. This one. Okay, you guys can take a screenshot from here, and you can easily understand what I have basically proved here with the help of the basic diagram. This one is the basic diagram. Thank you.